T minus 3, 2, 1, take off! Hello and welcome to the Cheeky Science Show, where today we're going to look at the consequences and biological impacts of going to space. And to assist me on my journey to space, we're going to talk about two different publications, one of which is the NASA twin study that came out last year, and one is a more recent review that looked at the impacts of space travel on acquired immunity. So let's start with the twin study, because why not? They have a really cool figure of the two twins involved in the study. Anyway, within the study they did a multi-dimensional analysis of a year-long human spaceflight. And the question they were trying to address is, how does the extreme environment, which is space, actually affect human physiology? And so going to space is no unstressful event. It's actually very stressful, and there's a lot of hazards and stresses that are involved in going to space. And to name just a few, some of the major stresses is microgravity, which is the feeling of weightlessness, the impact of radiation, the impact of circadian rhythm disruption. So in this study, the twin that went to space was on the International Space Station, and so obviously that orbits the Earth, and due to the speed that they travel, they actually orbit the Earth and go through 16 sunrises and sunsets in the space of one day. And I spoke briefly before about how they're trying to mitigate that. And additional stresses include just the psychological stresses of the fear and the loneliness, and also other stresses such as hypoxia. And so within the study they did a really big analysis of these two twins, one which stayed on Earth and one that went to space. Both of them are astronauts, and so this was a good study because you've got that genetic control. And so they did this study across 25 months that included the duration that occurred in flight. And then they looked at loads of different biological and physiological readouts that included things such as the transcriptome, so the different genes that are being expressed, and also like body mass and cardiovascular differences. And so when they had all this data, they then looked at the changes of going to space and then returning back to Earth, and characterized these changes into low risk, mid risk, and high risk in terms of health. And so firstly, let's look at the low risk. And so this is changes that they saw that occurred during flight but actually returned back to normal after flight. And so these include changes in the microbiome. They interestingly saw an increase in the telomere length, which I thought was really interesting. But they then returned back to a normal length after returning back to Earth. And they also saw apparently no major changes in the immune system, although obviously we'll come back to that later. And so in terms of the mid-risk health issues, they saw alterations in collagen regulation and intravascular fluid management. And so this is thought to impact blood clotting and vasculature changes. And they also saw some of the telomeres actually shortened in length. And so these mid-risk are called mid-risk because they didn't really know what the long-term consequences could be. But there were also high-risk, as they termed, health consequences. In particular, they saw genomic instability and chromosome rearrangements. But they also saw changes within the cardiovascular system, probably related to some of the mid-risk changes, and also changes within the vision and cognitive changes. And so the results were suggestive of cognitive decline, which, as they state in the paper, could have implications for safe mission operations, such as after landing on Mars. And further supporting genomic instability potentially caused by the radiation was an upregulation of genes involved in the DNA damage response. So I would say this study is very much a descriptive study because they pretty much just looked at the changes, and this was only based on one set of twins, so it was a very limited study. So what can we actually conclude from this? Well, one of the main observations they make is that, considering most things remain stable, human health can be mostly sustained from going to space. However, obviously we saw some high risk and mid risk changes, and so in the future they need to look for ways to mitigate these changes to prevent the biological consequences, especially considering planned missions to Mars. And so far we've looked at some of the challenges in space, but if we focus more on microgravity and radiation, we can also look at some more data that's focused more specifically on acquired immunity. So in terms of immunity, in our bodies, you can kind of split it into two. So you have the innate immune response and the acquired or adaptive immune response. So the innate immune response is often referred to as the rapid first line of defense. That includes things like your skin and your mucus, and macrophages, which are cells that gobble up other cells, so to speak. The acquired, on the other hand, is more adaptive, and it causes inflammation and is antigen dependent, so it depends on the pathogen that's got into the body, and relies on T and B cells. And so these cells are lymphocyte cells, and they derive from the bone marrow, and the B cells are matured within the bone marrow, but the T cells actually mature within the thymus, which is a different organ. And so, to cut a very long and complicated story short, when you have pathogens within the body, the innate immune system gets activated, which can also lead to activation of the acquired immune system, which results in the immune response, and also development, if necessary, of memory cells that provide a long-lasting immunity. However, some of these processes are thought to be affected by spaceflight. So, as I have just described, the bone marrow is really important for development of these B and T cells. But as is known from many studies, the bone is heavily influenced by reduced gravity, such that in astronauts they have a sharp decrease in bone mass. But the bone marrow also contains hematopoietic stem cells, and so these are cells that can differentiate into these B and T cells. And so it is thought that the impact of reduced gravity can also impact the environment of the bone marrow, such that the differentiation process can also be impacted. So in particular, they've noticed a reduction in ROA activity and CXCL12, which is thought to reduce the stemness of these stem cells. But whether or not that makes any sense, the key thing is that understanding how these processes are impacting the immune response and bone development will help in the development of regenerative medicines, not only for astronauts but also for patients such as those with osteoporosis. But it is not just the bone marrow that seems to be impacted by space travel. Studies have also shown an impact on the thymus. In particular, blood samples taken from astronauts have shown that there's a reduction in T cell output, and other studies, particularly done in rodents, that they can also model from Earth using clinostats and ways to alter the gravity. They've seen that there's thymic involution. And I mean, I just pointed out here that it's interesting that I previously spoke about a trial that's trying to improve thymic involution because it's a condition that's associated with age. So you should check out that video for more detail. Anyway, one question that you could be asking is, okay, fine, you see these potential changes in T and B cells, but does that actually affect the onset of disease? And well, actually so far, based on current reports, there are no reports that seem to show that astronauts are more prone to developing serious infectious diseases during or after spaceflight. However, one study showed that astronauts who stayed in a space shuttle for a short period, so 12 to 16 days, before, during and after the flight, exhibited a reactivation of latent viral infections. And so these viral infections are found in approximately 70 to 95% of the global population and include things such as the human herpes virus. And so whilst most of these infections are clinically asymptomatic, there could be potential long-term impacts that just haven't been assessed yet. Moreover, there isn't enough data to support a link between spaceflight and increased cancer risk. Nonetheless, given that there are plans to go to Mars, where there's increased irradiation and it takes longer to get there, impacts on spaceflight should really be investigated further to understand the biological impacts. And so I hope you learned something, and as always, thanks for listening.